Write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. To write a congruent statement for the triangles, you first need to identify the corresponding vertices. To help you identify the corresponding vertices, you can first rotate triangle YXZ as shown. Next, from the diagram, you can see that vertices M and Y are corresponding vertices, vertices N and X are corresponding vertices, and vertices P and Z are corresponding vertices. Now, when writing a congruent statement for two polygons, always list the corresponding vertices in the same order. So, a congruent statement for the two given triangles is triangle MNP is congruent to triangle YXZ. Now, because triangle MNP is congruent to triangle YXZ, their corresponding parts are congruent as well. To identify all pairs of congruent corresponding parts, first list the corresponding angles. From the pair of single arcs on the diagram, you can see that angle P corresponds and is congruent to angle Z. Also, from the pair of double arcs on the diagram, you can see that angle M corresponds and is congruent to angle Y. Finally, from the pair of triple arcs on the diagram, you can see that angle N corresponds and is congruent to angle X. Next, you need to list all pairs of corresponding sides. From the pair of single tick marks on the diagram, you can see that side MN corresponds and is congruent to side YX. Also, from the pair of double tick marks on the diagram, you can see that side NP corresponds and is congruent to side XZ. Finally, from the pair of triple tick marks on the diagram, you can see that side PM corresponds and is congruent to side ZY. This gives you a list of all pairs of congruent corresponding parts. In the diagram, quadrilateral DEFG is congruent to quadrilateral QMNP. A, find the value of X, and B, find the value of Y. In this problem, you are told that quadrilateral DEFG is congruent to quadrilateral QMNP. So, because these two quadrilaterals are congruent, all their corresponding parts are congruent as well. To help you identify the corresponding parts, rotate quadrilateral QMNP as shown. Now, in part A, to find the value of X, first notice that side DE corresponds and is congruent to side QM. So, by the definition of congruent sides, the length of side DE equals the length of side QM. From the diagram, you know that the length of side DE is 8 feet and the length of side QM is x minus 2 feet. You can substitute these values in for the length of each side. To solve for x, you can add 2 to both sides of the equation. This gives you 10 equals x. Therefore, the value of x is 10. In part B, to find the value of y, first notice that angle G corresponds and is congruent to angle P. So, by the definition of congruent angles, the measure of angle G equals the measure of angle P. From the diagram, you know that the measure of angle G is 84 degrees and the measure of angle P is 3x plus 2y degrees. You can substitute these values in for the measure of each angle. Next, you found the value of x to be 10, so you can substitute 10 in for x. When you simplify, 3 times 10 gives you 30. Now, to solve for y, you can first subtract 30 from both sides of the equation. This gives you 54 equals 2y. Next, you can divide both sides of the equation by 2. This gives you 27 equals y. Therefore, the value of y is 27. Show that triangle ABD is congruent to triangle CDB. Explain your reasoning. In order to show that triangle ABD is congruent to triangle CDB, you need to show that all pairs of corresponding parts are congruent. From the pair of single tick marks on the diagram, you know that side AD is congruent to side BC, and from the pair of double tick marks on the diagram, you know that side AB is congruent to side CD. Also, by the reflexive property of congruence, you can state that side BD is congruent to side DB. So, all pairs of corresponding sides are congruent. Next, from the pair of single arcs on the diagram, you know that angle A is congruent to angle C, and from the pair of double arcs on the diagram, you know that angle ABD is congruent to angle CDB. Now, notice that side AD is parallel to side BC. So, because side AD is parallel to side BC, you can state that angle ADB is congruent to angle CBD by the alternate interior angles theorem. So, all pairs of corresponding angles are congruent. Therefore, because all corresponding parts are congruent, you can state that triangle ABD is congruent to triangle CDB. Find the measure of angle P. To find the measure of angle P, you can first use the third angles theorem. This theorem states that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. From the given diagram, you can see that angle A is congruent to angle R, and angle C is congruent to angle Q because all right angles are congruent. So, by the third angles theorem, the third angles, angle B and angle P, are also congruent. By the definition of congruent angles, the measure of angle B equals the measure of angle P. To find the measure of angle B, you can use the triangle sum theorem. By the triangle sum theorem, the measure of angle B is equal to 180 degrees minus 90 degrees minus 52 degrees. When you simplify, 180 degrees minus 90 degrees minus 52 degrees gives you 38 degrees. So, the measure of angle B is 38 degrees. Therefore, the measure of angle P is 38 degrees as well. Use the information in the figure to prove that triangle WXY is congruent to triangle ZVY. In order to prove that triangle WXY is congruent to triangle ZVY, you need to show that all pairs of corresponding parts are congruent. To do this, you can use a two-column proof. To begin the two-column proof, you should start with the given information. From the pair of single tick marks on the diagram, you know that side WX is congruent to side ZV. From the pair of double tick marks on the diagram, you know that side XY is congruent to side VY. And from the pair of triple tick marks on the diagram, you know that side WY is congruent to side ZY. In addition, from the right angle symbols on the diagram, you know that angle X and angle Y are right angles. Next, because all right angles are congruent, you can state that angle X is congruent to angle Y. Now, notice from the diagram that angle WYX and angle ZYV are vertical angles. So, by the vertical angles congruence theorem, you can state that angle WYX is congruent to angle ZYV. Next, because two angles of triangle WXY are congruent to two angles of triangle ZVY, you can use the third angles theorem to state that the third angles W and Z are congruent. Now, notice that you have shown that all pairs of corresponding parts of the two triangles are congruent. Therefore, because all corresponding parts are congruent, you can state that triangle WXY is congruent to triangle ZVY. This shows that triangle WXY is congruent to triangle ZVY, completing the proof.